So for everyone joining in the recording, welcome to the recording. Sorry you missed the first 20-something minute, a half hour of it. Don't worry, we were just talking about ourselves. That's actually true, although it was in a useful and structured way.
All right, so I think that we got some quite good and useful tips from all of the biography part, and we will get back to the bios because we are going to use them to train baby GTP, which I think that if someone has any questions or wants to share any thoughts or ideas on this part, they're very welcome to do so. Otherwise, we can continue on with the next part of this session, right?
Yes, and while people think if they have things they want to share, we'll just go to the next slide, which is a reminder to fill in the attendance document. So it's live, and I'll put the link in the chat.
I can do that so that you don't go out of the screen share.
I actually have multiple screens running on me now, and I managed to do it all by myself, like a grown-up, or like someone who actually knows what they're doing, this kind of thing. Okay, so the attendance there, and again, both if you're interested in receiving a certificate of completion at the end of the course, but also if you want to help us keep track of numbers so that it looks good that we have a lot of people attending, then please fill out the attendance form. We'll try and remember to share the link at the end as well in case anyone missed it now. Maybe you just spaced out for a minute and miss it. No worries, we got you covered. We'll share it later on as well. And with that, should we go on to the next part where you start? We don't need to give them a minute because it's fairly low thought level filling in the attendance, right?
I think yes. And while we do the logistics of the screen sharing, people have some time to fill. So yeah, I will be changing a lot between windows, so sorry about that. I hope that everyone can see my screen properly. Michael, that's correct, right?
Yes, we can see it well. You're not presenting the slideshow, but I think that's intentional because you're switching.
Yes, that's intentional because I will be switching a lot, but still we have a few slides just to keep track of what we're doing. And yeah, once again, apologize for my voice. You have to listen to my voice that way throughout this next part of the session, which will be on training our very own language model, which we created specifically for the task of this course. And something that I'm going to repeat a few times is that if anyone wants the code for this, if anyone wants to play with it, train it themselves, develop it more, I will give you the code, send it to you because it's all open for everyone anyways. So yeah, if someone wants the code, because I don't want to bother everyone with that, just please, you can write it in the chat now. You can write me an email at any point and I will give it to you. So yeah, as you see in that on that slide, the birth of baby GTP. So it all happened in a conversation between me and Michael about ChatGPT. We were really playing with ChatGPT, trying to get it to give us weird answers and stuff like that. And we were talking about how it's a thing that is such a complex model that's trained on such vast amounts of data that it is beyond the human imagination. But we still wanted to see if we can show people the essence of this stuff with some relatively low resource ideas. And that's how baby GTP was born, which is essentially a very, very simple neural network, more like three very, very simple neural networks because there's three models, which has essentially the same task as ChatGPT. It takes some amount of text, some text that we give to it, trains on that text, so it finds the words, memorizes the connections between the words and how they're formed in sentences. And then when we give it some kind of a prompt, it starts to generate text. So in its essence, baby GTP is like ChatGPT because ChatGPT is nothing more than a text generation. Something that I love to repeat over and over again is how ChatGPT does not know anything. It does not have the sense of knowledge, or it's not some encyclopedia. It's simply a very, very good text generator. And this here is a very, very bad text generator, as you're going to see now. So I'm now going to...
Well, basic might be a more appropriate word than bad.
Oh, come on, it's bad. So I'm going to show you the code, and I know that probably most people here are not developers, or some of you are. It's written in Python for the ones who know Python. But the code itself doesn't matter. I will show it to you just like for the sense of completion, but you really need to be okay that if it doesn't make any sense to you. But what I want to tell is what I told a little bit earlier, that we have essentially 3 neural networks, because I wanted to demonstrate how different types of networks, different types of models handle data differently. So the 3 models that we have, the first one, I have put an illustration of how it handles data here. It is a dense model, or a simple, the most basic type of a fully connected model, which means that we define a couple layers. So you can think of them as a couple of floors on which the data is passed. And on each floor, each point of the data is simply connected to all of the points on the previous one and all of the points on the next one. So this is the most basic type of neural network. The input we have, the output, the neurons that are inside, and each neuron is connected to all others. For the ones here who are more into neuroscience and so on, imagine like all neurons connected to all other neurons in your brain. So it's quite an inefficient network, but mathematically it's very simple. The second one is convolutional, which scans the data in a little bit different way, defining some weights, multiplying, adding, stuff like that. This is how a convolutional neural network for 2-dimensional data would look like. And the third one is the most complex in terms of like mathematics, and it's an LSTM model, which stands for long short-term memory, which means that the weights are adjusted also backwards. So it has a little bit something called backpropagation. And when it looks at part of the data, it also looks at what comes before it. So it has a sense of time and a sense of memory, which makes it really the most complex model of the 3, because the first 2, they don't have a sense of time and sense of something came before something else. So if we look at the code, which is this, Michael, can you confirm that everything is seen correctly?
Yeah, it's a bit small if you want us to like read all the different text. Like I've got a pretty big screen here and I can read it if I lean in, but I'm guessing people
Yeah,
don't need to be
I'm
able to
not
read
gonna
every word, right?
I'm not going to enlarge it very much, because after that it's very hard to bring it back. So because I also really don't want to read the code now, just want to show you how it looks like, because basically what happens is that we feed the
You just
text.
want to show us that there is code, that you're not just making this all up. Like,
Imagine, yeah. So we have a function which pre-processes the text, which basically turns the words into numbers, because computers work with numbers, and in the end, the text that we are going to process is simply going to be turned into a chain of different numbers. That's what happens here in the first part of the code, and that might also be useful for the ones that want me to give them the code later. So we have the 3 functions for the models, which I
well,
already...
and like an interesting thing just to share, like what I learned from you explaining that to me and kind of foreshadowing for what we'll see next week is that's the same thing that happens with image recognition. And once you're converting either a string of text or an image into a binary string, then the algorithm is matching similar binary patterns to another. So like looking for similar strings of ones and zeros, regardless of what the input data was. So trying to think of what to call it, like the comparison is actually being done between strings of binary digits, and it's done in a similar way, no matter what the network is dealing with. It's just the transformation from either text or image or any other data source is kind of the key part here.
Yes. And in the end, we just want to transform whatever data we have, like in whatever form it is, into proper arrays or matrices of numbers. That's what happens here in the beginning of the code. Then we have the 3 models for which the snippets you already saw on the slide. And yeah, all of these rows really mean adding floors to the model architecture. And then we have the text generation, which takes the model and basically regenerates the text. So this is how the code looks like. And now we're going to set it in action. And if we want to go actually back to the slides, just so that you know what happens next, is that I'm going to show you how training a neural network or training an algorithm looks like. I don't know how much about this I talked in our previous session, but the thing is that training, so Michael, please tell me if I'm repeating myself. Training is like showing the data to the model again and again and again. So if we show some information to someone for the first time and we only tell them something once, they might remember it, but they might not, especially if it's like a complicated thing. But then if we iterate and show them the same information again and again and again through different examples, there's a good chance that after like 10 iterations, they will learn it. And after 20 and after 30, they will become better and better at this. All of you math teachers, for example, if anyone here teaches mathematics, think of teaching students how to solve a certain type of equation. You show them how it's solved once, then give them some example to solve. They will most probably fail because they've only seen it once. But then you make them solve 10 different examples and they'll get better. They solve 20, they'll get even better. And for example, if they solve 150 different instances of the same type of equation, they will pretty sure be able to solve every instance. So the process of training a neural network is the same. Each epoch means this is the one time you show the data to the model. And to demonstrate you how this works and to finally train baby GTP, we are going to enlarge my screen first so that it's properly visible. And then I'm going to show you the first bit of information that we're going to use to train our model. And it's going to be the text of a song. And this song is going to be important later. So it's good to either introduce it now to you, the ones who don't know it. And I'll be very happy if some of you already know it because it's American Pie by Don McLean. So, by the way, while I can show you how it looks like. This is the lyrics. And can you very quickly in the chat type whether you know the song or not? And Michael will monitor the chat for me.
And we can, well, no, I guess that's two questions at once. I was going to say we can ask who was at the Scientix webinar where we presented this already. But already, like looking at the names, I'm fairly confident it's roughly a third to a half of the people. So some people will be familiar with this. For that proportion of you, sorry if this is a little bit repetitive, but it's good to see it in the context where we're about to go further with it. Because in the 2 weeks, 3 weeks since then, it's easy to have forgotten some of the details as well.
So please write in the chat if you know the song or not. Michael will see this. And not to waste any more time, I'll just read the first few verses for the ones who don't know the songs to give you an essence of how it sounds like. And I obviously, when I have a voice, I'm not a good singer. So imagine if I try to sing now. So I'm going to read. And
but you're usually a great singer?
you know I'm not. So the song goes as follows. A long, long time ago, I can still remember how that music used to make me smile. And I knew if I had my chance that I could make those people dance and maybe they'd be happy for a while. It's a beautiful song, actually. It's from the 70s. And we're going to use that text. The other good thing about the song is that it's very, very long. So it has a lot of words for our algorithm to train on. And I'm going to actually run the algorithm. And you can see that this is all very, very raw, so not very user-friendly. But when we run the program, it asks us which information file we should use. So I'm just going to write americanpie.txt, which is the file with the song lyrics. Now, as I told you, we have 3 models. And for the idea of this, we're going to use the LSTM model, which is the hardest one. Not the hardest, but the most complicated one. And now the number of epochs. So remember, one epoch means we are showing our model this text once. And we're going to start with 10 times. So this is going to be very, very quick. There we go. And what you see is for each epoch, our training gives us an estimation of the accuracy. So this is the important bit, what it says here, accuracy. So it gives us an estimation of the accuracy to which it was trained. And you see 0.1 out of 1, that's not very good. So now, in order to use the model, we require seed text. Think of this as the prompt you give to ChatGPT. But here we call it a seed because it's something to start with, and it's the seed for generating the text, because our tool is much more primitive. And I'm going to actually give it the way the song starts. If you remember, it was a long, long time ago. I can still remember how that music used to make me smile. So I'm going to say along. And let's see, it's going to ask me how many sentences I want to generate, and I'm going to say 2. So you see what happened. Along the some number of times that it defines as 2 sentences, but basically only the word the is repeating over and over again, because our model really wasn't able, for the small amount of epochs it had, to learn exactly which word comes after which. So
and just a small thing to add to, other than being too small an amount of epochs, if you look at the accuracy, it didn't change at all after the second step, which is a sign it's not improving the model at all. So it was obvious before we tried any output, it would be terrible and not actually do anything.
yes. And of course, the word the and not any other word, because it's probably the most common word that is found in the song.
75 times.
Yes. So it just found the one piece of data that is most likely to be found in the song and started repeating that over and over again. So now we're doing the same thing, but instead of 10 epochs, we're going to say we want 100 and repeat the very same thing. And if you see, it's training pretty fast. The reason for this is that I'm not training it on my computer, which I'm presenting right now from, and I'm training it on a remote computer back at my office, which is quite better. So you see that for 100 epochs, we went to a 0.5 accuracy, which is quite good. So I'm going to give the same seed along. Remember, for 10 epochs, we only had along. Now we also want 2 sentences. And we get something like this. So it's still bad, but it's not only one word that is repeating over and over again. We have along was time had dance to dance, the music was the bright, but bright, whatever. So this got better, and we're going to do it one last time, and this time we're going to give it 200 epochs.
And just before it starts training, it's interesting how it broke after 2 words each time there. And that reminds me of when we were talking about how does it know how to do punctuation. And I think the way you went for in this model, and I'm not sure, you may have improved it since then, but one of the ways of doing it was just ignore that punctuation is different and it gets chunked with the words where punctuation goes. So then you'll end up with punctuation in it. Well, was it left like that, or was something more done?
In the end, I just taught it to ignore all punctuation, because punctuation is something very, very hard to process when we're doing text processing. So I didn't end up solving the punctuation issue. So giving it 200 epochs now, and again, it should be fairly fast. And you can see the accuracy. Now that we have more epochs, you can actually monitor how it becomes better and better and better. So for 200 epochs, we were able to bring it at about 0.8. So now when I want a long 2 sentences, we get 2 sentences. So I'm gonna read what we have. Along was sweet, him on dance, I, B, dance, watched forward, watched up to the levee, knew I could make dance, and so on and so on. So clearly this is still bad, but you can see real time how it becomes better and better the more times we train it, the more times we show the data to the model. So with this, I wanted to show you how training matters and what it means to train an algorithm. And again, I want to make the parallel between training an algorithm and training, teaching a child or student something, and how it becomes better after more and more iterations. Basically, this is a proof of practice makes perfect. So I told you that we have different models. And LSTM models are the best for text processing, like what we saw. But for the sake of completion, I also created a few other models. And just so that we do not use precious information, I want to rename the models because later we might want to use them again. So I'm going to rename the next model the convolutional model, and we're going to repeat the very same thing with the convolutional model. But for us to be able to compare, I'm going to edit this and show the output of the different models. So we're going back here. So we're again using American Pie. But now we're going to use the convolutional model, again for 200 epochs. You see how it got unstuck pretty quickly, and it actually gets to higher accuracy much more quicker, but then it kind of gets stuck at a lower amount for the accuracy. So now when I go to a long 2 sentences, we get something that's a little bit worse and a little bit more repetitive, because if our metric is really how repetitive everything is, then this has dance, and there you can see it here, a long word was, and basically a lot of there, dance, there, 1B, 1B1, well, and so on and so on. So it's worse. And the reason is model parameters. We're going to do it one last time. With the dense model. And convolutional models, they are very, very good for images, for example. They're also good for the data I use in particle physics. By the way, I also work with convolutional models. But long short-term memory is perfect for text. And you can see the reason with this, because when we talk about, even when we talk, we use phrases, we use sentences. Words don't go separately. Words go with other words, like some adjectives go with certain nouns and so on. And long short-term memory, it back propagates. So for each word, it is concerned with what comes before it or what comes after it. So that's why it's so good. So long, one last time, 2 sentences. And this is what we have. So you can see how a long lost in a code he borrowed from James Live once 9 American friend. This was quite good, actually. And the reason for this is that maybe the parameters of this model, I'm going to put this here. The parameters of this model I might have set them optimal for the song. So there we go. And you see how the same number of epochs, the same information, just different architecture of the models gave us different results. So one other thing, and I might skip this for now because I intended to show you how it performs on the whole book, but now we have a whole book of biographies by people. So instead of using just some random book that we chose, we might actually skip it to the biographies of you, which you submitted to us. Let's train now all of this one last time, but this time, instead of American Pie, using all of your biographies. And I'm going to show you very quickly how they look like. So this doesn't say which one is AI, which one is not. I have just copy pasted all of the results from everything that you have submitted, including mine, and so on. So we're going to use this to train. And while it is training, because it will take a little bit more time, like it will take like 2 minutes, for example, Michael can tell us about the other biographies that he wrote himself.
And do you think I should share my screen for that? Like share the prompts that I gave?
Yes, but just in fact, people already saw how this is trained multiple times, and it's not going to be any different. So yes, I can give you the share now.
Okay, so now I'm going to take over sharing, and yes. Yes, here we go. Here's the chat I had with GPT. And first I got it to generate a bio for me. And then I encouraged it and said, this is a good start, but research me more. And now I want you to make 10 different styles, each with a different style that came out. So the one that tricked most of you at the beginning, where I said as human-like as possible and cued it to possibly include some mistakes. We can also see some others. I think my two favorites were what it came up with as a poem and as a Ninja Turtle and 90s style surfer. So let's look at those two. So as a poem, he biked through lands both far and wide with science experiments by his side. From particle shows to physics grand, he brought new ideas to many a land. In humble laps, his work takes flight, turning science mysteries into light. And so it explains how it came up with poetry using imagery. And so without sounding too boastful, I don't know if it hit that right on the mark. But then that's another fun one I thought to mention. I said, try and write one like it would be in a Tinder profile. So like for a dating app. And so it really seems to exaggerate like the geekiness. And it says, yeah, swipe right for fun science puns and maybe a physics lesson or two. So that was a fun one to try. And then the surfer slang. So, dude, Michael's like the raddest science guy out there, man. He's been shredding roads on his bike, hitting up countries with killer science experiments, and so on and so forth. And of course, none of these individual. The boring physics vessel. If you want to read in the background while I'm talking about that one, that's a pretty good one as well. Kind of making it seem like everything I do is half failure, which could be the case. But it's good to get a variety. And if I wanted to, like, for example, if I were stuck trying to write my own bio for myself and I looked to GPT for help, then this would be one technique. So I'm not just getting it to give me a bio I'm going to cut and paste, because that would sound robotic, that would use too many adjectives, that would be too boastful. But I can use it when brainstorming, getting a variety of different ideas, and then say, I kind of like this element, or I kind of like another element of it. And with that, that's probably been more than enough time for our baby to train, right, Kalina?
Wait until I unmute myself. No, it's still training, but it's halfway done. But I need to use this other few minutes that it will give me to actually introduce a concept that is very important.
Okay, so I'll stop sharing, but I do have more bios. I have like the next things I asked. I have a whole ballad about myself that it wrote.
Yeah, still, if anyone wants to see the ballad ChatGPT wrote about Michael, I'm sure you can show it later, because I want to talk for a few minutes about something that's important. That is called overfitting, because no matter if you saw the Scientix webinar or not, so the ones who were there already know the concept of overfitting. But even if you weren't there, all of you have already seen overfitting a few minutes ago, because we trained baby GTP on the text of the song for a different number of epochs. And if you saw, for example, the first one that only said the, I told you that it chose the because it's the most commonly found word in the song. And there is this thing called overfitting that baby GTP does a lot, but ChatGPT also used to do before they made it good, which is when you develop a model that is way too complex for the amount of data that you have. And when that happens, it can learn by heart basically the data. So any data that it has already seen, it can repeat perfectly. But when presented with new data, it cannot produce anything meaningful. This is what's meant by overfitting. So once again, you have a very complex model and you do not have enough statistics, you do not have enough data to fill it with, to make it learn, to adjust all of the parameters to it. So this is what's known as overfitting. There's the other thing, which is called underfitting, and it's quite the opposite. So that would be when a model has too few parameters for the amount of data that it has. And basically, it just cannot find all of the relations. And again, it shows basically the same results. But anyway, to have introduced this concept of overfitting, that's what it means. If you want to think of it on a more like everyday level, that's trying to explain a very simple concept with a very hard explanation, like a very complex explanation for something so simple. Something that I think on like the spur of the moment is when in ancient but not so ancient times, people were observing the sky and were trying to explain all of the motions of the planets while still keeping the Earth in the center of the solar system. So they developed incredibly complicated mathematical models with these things called epicycles for the planets to follow and so on, just to explain that. But then that would have probably failed if they tried to explain a different stellar system. So yeah, the ancient people overfit as well. But baby GTP is trained. So I'm going to share the screen one more time. And Michael, it's visible now, right? I think it is.
Yeah, it's visible. Yeah.
So I decided to be generous and actually give it 300 epochs. And just quickly gonna scroll through the training. As you see, we reached about 0.9 accuracy. So now it's trained on all of you's biographies, both the real ones and the AI generated ones. So as a seed text, we want to use a person's name or something to start a biography with, which would generally be a person's name. So how do we do that? Do we use one of our own names? Does someone want to be a brave volunteer? Or do we simply start with I am? Michael, help me with that.
Start with me, because we've had enough bios about me. So Michael is, or just Michael is it?
Let's start with Michael is. And we're going to ask for 5 sentences. And the definition of a sentence for our model is very weird. So don't ask about that. But basically, at least when we tell it how many sentences we want, it gets a rough estimation of how many words to give back. So we're gonna need to wait a few seconds for that. So Michael is earned a Guatemalan physicist from Universidad de San Carlos de Guatemala. Master's degree on e-learning, PhD in something the Zoom controls. Okay, PhD in sustainable development and PhD in public administration. University professor for 28 years. Globe Teacher certified, founder of the STEAM program, State Department alumni of Hidden No More IVLP, winner of the 80 Faces of Exchange Award School of Community. The teaching has only grown stronger with time. I love being involved in projects as her teaching on education. He have been published in prestigious international dedicated on mathematics and computer engineering at the University of Madrid, at Manzanares, from National, and this is where our 5 sentences end. So You see, it was able to, even though it's an incredibly simple model, one thing I should emphasize on over and over again, it was able to generate a pretty good biography for a person, only using the biographies that you guys wanted, you guys submitted. So this model is now saved. And if anyone's interested, we can continue actually generating biographies for different people, but because we're running a little bit short on time, let's keep it only to Michael's biography, which I'm going to paste in the presentation to here. So if anyone's interested in Baby GTP generating their biography based on what you guys have submitted, you can let us know in the chat, and I'll very quickly make this happen. And should we move on to overfit now?
Yeah, and were we going to do the tips for AI generation before or after overfit?
Let's do it after overfit, yeah.
Okay, sure.
So I'm leaving you the share.
Okay. And will we go over how to generate their own overfit, or just go through the American Pie one, which we already did in the science webinar, or will we try and fit both, or overfit both?
Let's try to overfit both.
Okay, so my new favorite game, invented a couple of weeks ago, just in time for the Show Science Festival in Morocco. Yes, now sharing my screen again. Yes, I am, right, Kalina?
Yes.
Okay, perfect. Okay, so this is a game that we've trained on a couple of things, including a song in Bulgarian. No, we didn't do a song in Bulgarian, but it's been trained in French and only French and English? Almost. But you guys could be the next ones to train it in your own language. So what we've done is we've taken word counts of different words in the song American Pie, which we saw and we trained GPT on. So good sample data set to use. And we're looking for the most frequent next word, because that's the first part of a predictive text model, looking at how likely is it that would be the next word. So we'll go, and I know I'm not in slideshow mode, that's so I can take out things that are blocking the words. Let's skip to the most common word in the song, because that came up earlier. The occurs 75 times in the song, and we want you to guess in the chat what you think the most probable next words after the would be. So how often, like the next words for the song. And I've gotten to a way where I can't see the chat. Kalina, can you tell me what comes up in the chat?
Yes, 1 second. Still waiting for guesses. I think a lot of people said that they know the song.
Live. Is live in there, Kalina?
The levy. I think that live also stands for the levy.
Oh, right. Levy is the, oh, I don't remember. Why don't I have my answer key handy? It's the third most common, right?
I can check.
It's either the third or the fourth.
No, I cannot check.
No, it's the third. No, oh, no, it's the fourth most common, and it occurs 7 times. No, not right at all. What? How? It's not this day. Well, I'm just showing you all the answers. Levy is the second. Levy is okay because it's in the chorus. Okay, but then the day the music died, and the day is by far the most common with 19 occurrences. So. Remember how Kalina trained in 10 epochs and it said along the? That's because with 75 occurrences, it's by far the most common word in the song. Let's move on to another one. Following the word I. in the song. Any guesses what words could follow I frequently? Started. And Kalina, if you don't have the answer key somewhere else, then I'll quickly pull it up because I do have it open in another tab. It's just not the right tab.
I will get the answer key in a second.
Okay. Any other guesses? And started only occurred once, so we don't actually have it on the answer board because we only have ones that occur at least twice. The chorus includes "This will be the day that I die." So "I die" is by far the most common occurrence after "I." So it occurred 12 times. And of the 34 occurrences of "I," there's only 6 other occurrences of words that occur more than once. I'll just go ahead and reveal all the answers. So "I knew," "I saw," and "I was." And I deleted "was," but was the word that was supposed to go there. Was the word? Okay. Was, okay. So that's how the game works, but you can generate the game for any text body. Kalina, do you think you want to take the time to explain how to do this with the nifty little program you wrote?
Yes, so very, very quickly, if you want to create something like this generally goes for any text where you want to show people that they can actually work like an algorithm and predict what word would come after another word. And song lyrics were chosen here because it's songs a lot of people know. But if we think as in terms of the biographies that you guys sent, we can also check if we can predict for some common words what could come after another word. So, for example, in many biographies, people say where they were born. So it's only logical that after "I was," the word "born" might occur very, very frequently. And I have actually developed a little piece of code to demonstrate this. And I'm going to show you very quickly again. Let me just, because I'm also generating biographies for the people who asked me to. So everyone who asked me to, I will get you one eventually. But before I continue with this, let me show you the word counter. So this here is once again the file with the biographies. And you can see there's a lot of them, and it's actually not complete, which is a good moment to get these last few that I pasted while we were already going, and there we go. So now we have all of them. Save the file. And the little counter works as follows. So again, it's not very user-friendly. It's a piece of code. And it uses this bios.txt file, which is over here. And the whole thing that I'm showing you, for the ones who don't know, is called Jupyter, and it's an online Python compiler. So I have the file here, and I also have the code. And for example, if the target is "I was," so as target, I write "I was." When we compile it, we see that "I was" appears 10 times in you guys' biographies, and 7 out of 10 times it is followed by "born." So something that I already told you. We can easily predict what would come after a word. So give me another word to try this. Maybe "studied." A lot of people talk about where they study. Oh, no one no one has written the word studied. Okay, that's my bad. A lot of teachers. Okay, let's try with teacher. Oh, there we go. So the word teacher appears 21 times in all of you guys' biographies. And we can see that it's followed 3 times by trainer, 4 times by for, and we also have the word passion. Very good. So this is the
How many times did teacher occur?
21 times.
21 times.
Yeah.
And what was it followed by?
You can you should be able to see it.
Yeah, but it's small.
Oh. There you go.
Okay.
So I can also give you this, and the idea is that it's a good classroom activity to do, whether with some commonly known texts or other things like that, and to see whether people can use their minds, work as text generators, and try to guess after some word what would be the next one to come. So I'm going to cheat a little bit and look at your biographies really quick. Okay, my name is something quite good, or some more common things like I'm doing this live, so I do not have endless ideas. But if we write one more, my name appears 5 times, and all the times is followed by is. So yeah, this can also show how humans can try and think like computers. So it can be quite a good classroom activity. It can also be developed with many songs that are popular in different countries. But the songs need to have something that's repetitive in their lyrics so that the game works quite well. So yeah, this is the tool. I'm now going to give up the share.
Okay, so we're back. Recording is back on. Okay, so as I was saying, and I think you took over my screen share when you reconnected. Okay, either that or I didn't do it properly to begin with. Can you see my screen now?
Yes.
Okay, so while Kalina was doing that, I created the new overfit slide for teacher, like I just explained, and so people could guess what the most common next word after teacher was, and it was teacher 4, I think, occurred 4 times, yes, and then trainer 3 times. Oh, not trainer. That's the problem with typing while trying to read off of Kalina's screen. And 2, I think, and then I didn't catch more occurrences because she switched what she was doing. But that's the idea of how you train the game.
Can you please real quick make me host again so that I can reply to people who wanted BIOS?
Yeah, of course. Okay, so here we go. Welcome back as co-host. Okay.
Thank you.
So as I was saying, there's a couple of template slides. Really, there's only need for one, but once you have the slides, if you want to make your own version, then you can make your own version using this template here. Of course, if you make something fancier or better, please share with us, because this is just kind of functionally good enough, but you can see we were going for function rather than beauty. It could be a lot better. Let's skip. We're getting to the last 2 slides. Well, I guess the last 3 slides, because there's one with our email addresses on it, which you have already. But tips for prompting AI generators. With everything we've learned in this session today and how we've trained both baby GTP and how we've looked at how we prompt different models, write into the chat any advice that we've gathered that could be good for prompting AI text generators like ChatGPT.
Also, Michael, while we're doing that, can you please, because I cannot see the chat, someone also replied to Selma's comment that they want their bio, and I cannot see that.
Valentina.
Oh, okay. Thank you.
It looks like people are either shy or maybe falling asleep by this time in the evening, so we're not getting many chat-generated tips. Oh, here. No, that's a question rather than a tip, right? What structured language is more likely to use at chatbots? Kalina?
I'm not sure I understand the question, to be honest.
But let's hold that question if we still want it answered after, and just quickly go through a couple of tips. So if we don't get input, but if you think of anything you want to add to the advice, the idea was to have this community generated or with things that you think you've learned from it. But I'll start it off with a couple of my favorite tips that I've already mentioned so far. So one of them is to consider generating a large quantity or large variety and to use it for brainstorming and narrow down for there. So use for brainstorming ideas and feel free to ask it to generate several versions of the same text. And something related to that that I didn't explicitly mention or go over, but I've been talking with Kalina about as well, and it's something you might find from your own life, either for things you generated or maybe a friend has generated, and they say, hey, check this out, is as humans, it's in our nature to pay attention to read something that someone has written for us. If you're writing for someone else, it'll take you more time to write than it will to read. So it's simple courtesy to read anything that anyone sends you. But with text generation, you can generate several times faster than you can read. And this is one of the first times in human history that's the case. So we're programmed to want to read everything that's generated. But if you generate, like I could have asked, instead of come up with 10 versions of my bio, come up with 100 versions. Come up with 1,000,000 versions. I mean, maybe it would refuse 1,000,000. It might say that's ridiculous. Come on. But I could have it generate more than I could possibly read today with only a couple minutes of prompting. So the next is be aware of how much time you spend reading output, because it might not be the best use of your time to read everything. And do we have one or two more points we might want to add to this before we move on and finish? Kalina, anything you have to add?
Especially for prompting, always keep in mind that the result is only as good as the prompt is. So always try to give as many details as possible. Vague prompts wouldn't get you far, and that's especially important when teachers are trying to generate, for example, lesson plans and something like that using AI, because it can be a powerful tool, and using text generation can really help. So you need to be as detailed as possible, as Michael put there in the what do you want to achieve, what are your goals, what are your students, and all of this kind of stuff. So details matter.
And details on what you want the output to look like, because if it doesn't know, it will give the most probable output, or like what it guesses you might want the output to look like.
Yeah.
And I think we'll leave it at that to take 1 minute to explain homework for next time. So, oh, and I can go back to slideshow because I'm not editing. So as I mentioned earlier, today at 11:45 today, so like only, I don't know what time it is, 7 hours ago, something like that, the 2024 Physics Nobel Prize was announced, and it was awarded for physics developments for machine learning. So the article explaining the science behind that is an interesting read. It's not a very long read. Well, depends on what level of detail. I was assigned to write a congratulatory post on the European Physical Society on it. So I read it several times to make sure I got it right, but just feel free to read it only once for the homework. You don't need to. So read that. And then Steve Mould is a popular science communicator with probably my current favorite YouTube channel. One of his most recent videos explains image generation in AI. Oh yes, of course, I'll give both of these links in the chat. I had them ready to copy, and I've probably lost the other document with it, but I'll put it in the chat. You'll also get this by email. I'll email with a link to the slides. Also, you'll get the recording, but those of you who were here are probably not the subset of people registered who are most interested in the recording. and they'll miss the first half hour where we introduced ourselves anyways. But there might be a couple of delays for getting out this week. There's a couple of delays at my end, so don't be surprised or worried if that doesn't come out before the very end of the week, possibly even early next week. That's just the kind of week it is this week. So yeah, those would be good both for looking at machine learning in the news, but the actual, like what the prize was awarded for and the techniques are going to be useful probably for 2 sessions for now, but because it's in the news today, like it's less than 7 hours old, this news, it seemed fitting to recommend that you guys read it today. So that brings us, that should bring us to an end. I should remember how to switch my slides. And the link to the slides, which I'll also copy and put in the chat, and our contacts, which you already have because you received the invitation to come. But if you have any questions, don't hesitate to reach out to us. I think we've been good at actually replying to everyone. So sometimes I'm not so good at that. If we miss anything, just send us a second email. But I think we actually replied to everyone.
Yeah. Also, before we end, I want to add something that's concerning the today's news about the Nobel Prize, because I want to share with you guys is that today I was actually speaking at a conference, at a physics conference, which was full of a lot of physicists that were quite skeptical of applying machine learning methods to certain things. So it was quite a nice feeling just after they announced the Nobel Prize in Physics goes to the people who helped develop neural networks to go at a conference and speak about applying such neural networks in your data analysis. So that's something I did today that I wanted to share with all of you guys. And just to show you why this prize is so important, especially for us young scientists who want to introduce more and more artificial intelligence, machine learning, and all of this kind of stuff into science and into, let's say, the more common and usual methods.
Well, and it is pretty cool how they came up with like both John Hopfield and Geoffrey Hinton, like their contributions were different, but they both used a different part of physics to model the problem and how you'd have a related network. Like Hopfield networks use an analogy with spin and how the magnetic alignment of different atoms interacts with each other based on distance to look at connections in a network. And then Hinton used statistical physics like thermodynamics, and both of their work looked at optimizing a pathway or like finding a lowest path as an analogy to lowest energy solutions, like looking for a potential energy well. So it's kind of cool how physics that wasn't necessarily related to anything computational or algorithmic was applied in this way.
So yeah, we can talk about this more in the next sessions if anyone's interested. So let's wrap it up from here. Yeah, someone wanted the code of baby GTP. I will send it to you. Okay, so if anyone didn't fill the attendance form, and
okay, I'll add the link to that one last time.
yeah,
And
but all in all, I have more requests for the code, so I am writing down both of your names so that I can send it to you. And we're hanging out in this meeting for a little bit more time so that if someone wants to ask something or to tell us something, we're still here, no matter that it's past 8.
was 7 for where I am.
Oh, yes.
Okay. But yeah, like what Kalina was saying is we're done. Have a good evening. But if you want to stick around, we'll stick around for a couple minutes for anyone who wants to hang out for a couple minutes to ask any last questions. But thank you for joining us and have a great evening, everyone.